Okay, this lesson is about wave motion and the wave equation. So let's start by looking at a wave. Now a wave is going to travel, and we're going to just draw an arrow here. It's going to travel in the right direction. And we measure a wavelength by the distance between two identical parts. So that's going to be one wavelength. Now, as it's moving, it's going to have some speed v or velocity v. And we know that velocity is measured by distance traveled over time. But in terms of a wave, when we move one cycle, the amount of distance that we've traveled in a wave is just one wavelength. And the amount of time that it takes to go one cycle is just the period. So the key concept here is that the speed for a wave is going to be the wavelength times, well, 1 over period is frequency. So we can say frequency times wavelength gives us our wave speed. That's our key concept moving forward. Okay, let's take a look at the example in your packet, the first example. A sound wave in air has a frequency of 262 hertz, and it travels with a speed of 343 meters per second. We want to know how far apart are the compression. And they want to know how far apart are the waves. Well, we've got an equation for that. We've got speed of a wave is equal to frequency times wavelength. Therefore, the wavelength is going to be equal to the speed divided by frequency. And you have both of those things. So the speed, 343 meters per second, divided by the frequency of 262 hertz, which is just 1 over seconds, is going to give you a wavelength of 1.31 meters. Well, that's lovely. Let's try another one. This next example says that an ocean wave has a frequency of 0.07 hertz. And a wavelength of 10 meters. And they want to know what is the speed of that wave. Again, our equation, speed of a wave is equal to frequency times the wavelength, and we have both of those. We have the frequency of 0.07 hertz, and we have the wavelength of 10 meters. So multiply it out, and you should get 0.7 meters per second for your wave speed. Okay, you try one more.